Welcome back with another video on TryHackMe.com. This is Zaheen Nazir and we are doing DAST, which is the part of DevSecOps learning path on TryHackMe.com. It will take around 120 minutes, that means 2 hours, and it have medium difficulty, that means for us it will be 4 plus videos to complete this one, right? So I already deployed my attack machine and I already started the virtual machine, which is on task 2. And in this DAST room, we'll learn about dynamic application security testing. Okay, let's get into it. Task 1 basically will give you the introduction. So let's see what we have here. Introduction. One of the many ways to test an application for vulnerability is to take a running instance and attack it just like an outsider attacker would. This process is known as dynamic application security testing. Remember that DAST is separate than the pen testing, right? Pen testing is more of a manual testing, DAST is more of a automated testing. And both of them complement each other. Okay, these are not replacement for the pen testing, and will be focus of current room. Sure. Room objectives: learn how DAST can be applied to find weakness in real world applications. Sure. Understand the pros and cons of using DAST instead of other techniques. As we read in previous rooms, that DAST should be used in composite of with other techniques, not instead of. Okay, this is not a replacement. Familiarize yourself with some of the tools used for DAST. Sure, we'll do that. Room prerequisite: before attempting this room, you should understand how web applications and HTTP protocol work. It is also desirable to know about common web vulnerabilities. If you need to get a refresher on any of these subjects, be sure to check the following rooms: how website work, HTTP in detail, and OWASP 10. Let's see if we have covered this one before. If not, maybe in the later module I will cover the OWASP 2021 as well. Yeah, okay. So it have 23 tasks, so maybe in future videos will cover this one as well. But for now, we'll move forward. We hope we'll be able to tackle all the tasks in this particular room. Answer the following question, click and continue. We already did that. Let's continue to task 2. Okay. Dynamic application security testing, DAST. What is DAST? Dynamic application security testing is the process of testing a running instance of web application for weakness and vulnerabilities. It focuses on black box testing. That means you know nothing about the application. You just gather the public information and try to make your way from there. Okay. SAT was white box testing. That means you have the access to the source code itself and you can see actually what your source code is doing. But in DAST, you don't have the source code. You have basically a URL of the website which is published, and you take it from there. So as testing approach where vulnerabilities are found just like a regular attacker would find them. Simply put, DAST identify vulnerability by trying to exploit them. Not necessarily. If you exploit them, that means you could destroy the environment on which you are testing it. For example, if you're testing it on pre-production, and if you are exploiting it, for example, there is a vulnerability for SQL and you are exploiting it to delete all the data, that means you could destroy the healthy environment, right? So it depends on the tool configuration. If you want to exploit it to a certain level but don't make a permanent damage, some of your tool have this kind of settings there. So I mean, it really depends on the configuration. So mostly you don't exploit, you go for proof of concept. If you got the shell or not, you perform 1 or 2 commands and that's it. Okay, that would be enough for the report. Either manually or through automated tools. By testing the application from outside perspective, we can abstract ourselves from its inner working and focus on identifying vulnerabilities that an attacker would likely find. This means the result obtained from the DAST will often point to vulnerabilities requiring prioritized attention as they are expected to be found without prior knowledge of the application. It is important to note that DAST does not replace other methods to find vulnerabilities in the application, as I explained earlier, but rather complements them. A secure development lifecycle will often mix several techniques in order to provide a good enough vulnerability coverage. Yes, definitely. Manual versus automated testing. Manual usually pen testing में आ जाता है और automated testing usually आप DAST tool के जरिए करते हैं. There are two ways in which DAST tool DAST can be performed. Manual DAST, a security engineer will manually perform tests against an application to check for vulnerabilities. Consider that the DAST tool will perform on your actual application, right? With less layer than the production. Because if you perform this DAST, if you run this DAST tool on production, maybe it not be able to run it because you will have a lot of captchas and all these thing bots and automated tool filtering as well. So maybe your DAST tool will not work there. But what you do is you remove few of the layers, few of the security layers to test your application itself, right? So this is a must considered fact. Both processes are complemented. Okay. And the automated test and automated tool will scan the web application for vulnerabilities. Sure. Both processes are complementary and can be used at different stages of software development lifecycle, SDLC, secure software development lifecycle. Combining manual and automated tools will often yield the best results rather than relying on either separately. Definitely. I mean, just like SAT, manual code review and automated code review is a must to have best results. Same here as well. DAST, even though you have automated tools, if you combine it with manual, you will usually get best results possible. Manual DAST will help us find weakness that an automated tool won't easily spot, as they don't understand the application from a functional point of view or data flow point of view, right? So if there is any use case where user can exploit one of the procedures that you have written, obviously DAST tool is not self-conscious like humans, right? So if some engineer, security engineer is performing the DAST manually, that means he will be able to spot these kind of issues. Okay. The problem with doing everything by hand is that running manual tests for every commit or small change in the code during the development phases will take too much time. This is where automated DAST excel, as it provides a quick way to run many tests against the target application without requiring human interaction. That is true if you are doing it through automated testing. Okay. So here is the DAST in SDLC. I think DAST in SDLC, Secure Software Development Lifecycle, SSDLC, DLCM, downloadable content. No, it's not like that. Software Development Lifecycle. Okay. Plan, code. On the dev side, we have plan, code, build, and test. So on the code side, we were doing SAT, and then now on the test side, we have DAST tool as well. So this is our pipeline. This is our life cycle, and we are introducing tools as we go along the process. While every scenario is different, it is common to use automated DAST during the test phases. Automated DAST tool will often be optimized for speed, so developer can obtain feedback quickly, unlike a traditional web application vulnerability scanner, which could take several hours to run. Yeah, so vulnerability scanner is a different kind of beast. Okay. So it really depends on the tools that you are using. Maybe the DAST tool, maybe the web application vulnerability scanner can be used as a DAST tool, but on a setting which will quickly give you the results. For example, top 1000 vulnerabilities it can scan, okay, and then give you the result quickly. Then a thorough web application vulnerability scanner can be run maybe periodically, 2 weeks or 1 month after. So this can give you, the detailed information about all the vulnerabilities that it can scan, and give you the feedback that if this is the vulnerability is there in your system or not. Okay, which could take several hours depending on the configuration. Of course, the idea here is not to provide an extensive scan of the application, but to catch the low hanging fruit early, right? So the most, prevalent vulnerabilities, for example, 1000 most prevalent vulnerabilities could be scanned quickly. Manual DAST, on the other hand, is often run periodically to avoid slow down the development process as a whole. It is usual to run manual scans weekly while applications are being developed, but this greatly depends on each project. A more intense scanning profile can be used in these manual scans to identify even more vulnerabilities. Yeah. So the manual scan is like, so the automated DAST is, for example, you are using the DAST tool in the CI/CD configuration, or manual is you are running the software manually. You are configuring everything. You are bypassing the CAPTCHA every time and then moving along the workflow of the application. Okay. When the application is ready to go into production, running a full-blown web application pen test is always good practice to notice any flaws in the final product implementation. Most literature will often refer to automated DAST simply as DAST, and will often consider manual DAST as the part of the web application pen testing. Yes, of course, and we consider the same. Manual DAST is more of a pen testing that you do. Okay, manual DAST might also be referred as traditional DAST. Okay, so they are, new terms are coined every now and then, and they are mostly having the same meaning as the traditional one, but they just want to, market the technology. So that's why a DAST we have, and then we have manual pen testing, which is kind of old way of doing it. Still, it's the same. As with any other process used to find vulnerabilities in an application, DAST will have its advantages and disadvantages. Let's go through all of this quickly. Find vulnerabilities during runtime. This will include vulnerabilities that are specific to deployment process, which cannot be seen by analyzing code. Definitely, DAST will find vulnerability like HTTP request smuggling, cache poisoning, and parameter pollution that won't be found using SAT. Obviously, DAST tool don't care about the programming language in use by your application. Since DAST is black box testing, all apps are treated in the language agnostic way. Of course, DAST tool, we are considering it in a context of the web application. At the end of the day, it is HTML that it will return, right? So we will see your application as a language agnostic way. At the end, it is HTML, CSS, JavaScript that we need to scan. Reduce number of false positive as compared to SAT. That is true. That is very true. DAST tools might be able to find some business logic flaws. The effectivity will depend on the tool. Shouldn't be taken as a replacement for manual testing. Sometimes, if the tool is configured far enough to reach in the business logic flows, then if there is any flaw within the business logic flow of the data, then it will be able to pinpoint that there is an issue. Otherwise, manual, these kind of things are tested in manual testing, manual pen testing. Cons, what are the cons? Code coverage isn't the best. Okay, DAST may not cover specific situation that will only be triggered by specific use cases in your application. Of course, we know that. That's why we have manual pen testing. Some vulnerabilities may be harder to find using DAST as compared to static code analysis techniques. Yeah, there could be prerequisite that, for example, in order to bypass the authentication, maybe there should be, the HTTP only cookie should not be enabled, right? Or like that. And if the cookie is not enabled, then the data within the cookie should not be encrypted. If it is not encrypted, you could try to bypass the authentication by mentioning some name or roles within the cookie values. So it really depends, right? Some apps are difficult to be crawled modern application heavily rely on JavaScript processing for the client side. This makes it harder for DAST tool to traverse them. Not so much now because DAST tools are evolving as we go. Before, yeah, it was a challenge, but now it is not that much of a challenge now. DAST scanner won't be able to tell you how to remediate some vulnerabilities in detail since they have no idea of underlying code. If you enable server side tags, which will tell your DAST tool that which kind of application you are running. For example, if your application is hosted on IaaS, and if you are sending the server header from your server that your application is using .NET Core, this version, maybe DAST will be able to give you the remediation steps as well. But it will also, if you enable this one, it will also tell you that there is an issue, information disclosure issue within your application. Okay, so it is a kind of blessing in disguise and also a vulnerability as well. So it really depends, Yanni. So if you tell manually your DAST tool that these are technology we are using, at least if you are doing it in-house, so you will be able to get this information, and the remediation steps will be available for most advanced DAST tool. They will be able to give you some steps to how to remediate this issue. Otherwise, if it is totally black box testing, then they will just point out generic remediation step. But if your language or your environment need a specific kind of remediation solution, then it is up to you how you will gonna do it. So it's a two-way sword, right? If the information disclosure is available, then it will give you remediation steps. If it is not available, then it will give you generic kind of stuff. So it goes both ways. Some types of scans might take lots of time to finish. Of course, if you are using intrusive scanning, that means you will try to exploit the vulnerability that is found, and that it will definitely take a lot of time, and it could also raise a lot of alerts if you are doing it on production, which is a bad idea. Usually you do it in a separate environment by removing few of the layers, so it will make it easier to run the DAST tool or your manual pen testing. We need a running application to do testing. That is very true. Ready to DAST, ready to dance, and ready to do DAST. Okay. Most of the time, you will find DAST contextualized as a series of automated tests. However, we will explore how the manual process works to understand better what most tools fundamentally do. In general terms, a DAST tool will perform at least the two following tasks against the target website. So, as I told you, it is in the context of the website itself, published code. Spidering, crawling, and vulnerability scanning. Most of the time, it is spidering and crawling. Vulnerability scanning usually goes very quickly, and after that, once you do the manual testing, which is intrusive, that when in that case you will run full width of the vulnerability scanning, okay, on your application. Spidering and crawling, the tool will navigate through the web app, trying to map the application and identify a list of pages and parameters that can be attacked. Okay. Vulnerability scanning, the tool will try to launch attack payloads against the identified pages and parameters. The user can typically customize the type of attack to include only the ones relevant to the target application. Obviously, we will use Zap proxy or OWASP Zap proxy as our DAST tool. For demonstration purpose in this room, consider, however, that many DAST tools used in enterprise setups are paid and quite expensive, but will use the same base principle as any other web application vulnerability scanner. The main difference among tools will be in their vulnerability detection capability and how many additional features they add to their product that are useful in enterprise, like dashboard, ticketing system, integration, and many others. Definitely. So Zap proxy is open source, available free of the cost. If you are going for NAS's expert or something like that, definitely it will cost you a lot. and these are available for enterprise solutions only. Throughout this room, we will use a virtual machine. Since the VM takes a couple of minutes to start, it might be a good idea to click the start machine. We already done so. Button on the top right corner of this task now. You may access the VM using the attack box or your VPN connection. So we are using attack box here. If you are using the attack box, be sure to hit the start attack box button at the top of the pages. We already done so. Is DAST tool replacement for SAT or SCA? Never. It is nay. Awesome. What is the process of mapping an application surface parameter using usually called? Mapping surface parameter usually called application surface spidering and crawling. List of the pages and parameter that can be attacked, right? So this is, I think, what we are looking for. Yep. The DAST check the code of an application? No, never. They don't have access to the code itself, right? Okay, let's continue with the task 3. I hope that it would take more time, but now it is taking less time to do. We still have 10 minutes to go. I think we will be able to complete this room at least. Let's continue. Spiders and crawlers. Spidering an app with Zap tool. Z Attack Proxy Zap is a free and open source web application and security scanner. It is powerful tool that pen testers and security professionals can use to test the security of the web application. So we're gonna use that. The first step we'll take is to get a map of all resources in our target web application to identify the scope of our analysis. So usually, I mean, the site itself, the navigation and site map is available in the site map of the website. But still, what we do is we spider around the application and see the links and where it goes within the application and which other application it is going to. So we calculate all, we make a tree of all the site hierarchy, as you can see in the picture here. And after that, we try to run our attacks on top of it. Okay. So identify the scope of our analysis. Zap provides a spidering module that we can use to do that. And a spider will navigate to a starting page you provide and fundamentally explore the website by following all the links it can detect. Okay. And if it requires a login page to do that, you need to configure the login page as well. And if there isn't any captcha required, usually it is disabled in this kind of step. If it is not, then you need to do it manually every time. So this is how it will be done. To spider a website, you can go to Tools, Spider. This will show us the spider dialog where we only need to specify a website as our starting point. For now, we'll leave the context and user boxes empty. We can check the following additional option if needed. Okay, so this is the 10.10.128.78 is the website that we need to use, right? Yeah. So let me open here. Refreshing it. Tools. I hope tool is available here. We have Metasploit. We will be using Zap proxy, right? So additional tools. Here is the Zap proxy. Let me run this. Should be in the license page. Let us open it from here. Zap. It should be somewhere here. Web. OWASP Zap. This is what we will do. Use. I'm opening it. It will take a couple of seconds. As you can see here, it is working. Let's move on with the theory at least. This will show us the spider dialog where we only need to specify website as our starting point. For now, we will leave the context and the user boxes empty. These two boxes will leave it empty. You can check the following additional options if needed. Recursive, spider website for links recursively, spider subtree only, limit the spidering to the subfolder of the starting point URL. Show advanced option, enable the advanced tab where you can specify additional parameters to tune your spidering. Okay. Point to this one 10.10.128.75.8082, which is the IP address of a target machine. Press start scan. After a while, you should see all the URLs that the spider found on this site tab. So let me copy this one. All right. Has expired on the now. You should regenerate it and reinstall it. Regenerating certificate and go the relevant screen. Okay. Let's do that. Generate. Yes. Okay. What happens? Swear. I don't know what this error is. I do not want to persist this action as a moment at the time. I want to persist. Yeah, let me persist this this one, and let me add a site here. I will just add a site. Spider. Starting point is you don't have any site, so we'll add some sites here. Wait a moment. How we tools spider. Okay, let's go to tools. Here is the spider. Starting point is this website. Context is nothing. And we need to check two of the boxes. And then I need to click on start scan. As you can see in this site, we have these things available and it is 100% is done. Let's see what else we need to do. You should now see the site listed populated with all URLs found during the spidering. Yes, we have all the URLs. Any item outside your starting page URL is considered out of the scope and won't be added to the list. Obviously, we understand that. You might notice that if you navigate manual to this one, you should see a link in the menu that points to nospiders-gallery.php. But if you expand the site list on the Zab, you won't see this URL. Let's see what they are trying to say. I open the Mozilla Firefox. I'm gonna open new tab. I'm gonna copy paste this URL. And yeah, there is no spider gallery here, which was not part of our scanning. Why is that? This happens because this particular link is not directly embedded in the page HTML code, but it's generated on the fly by using JavaScript on your browser. as many modern applications do. Since the regular Spider in this app doesn't have a JavaScript engine, it has no way of finding that link. Okay. More Spider. To overcome the limitation of Zap's regular Spider, Zap can leverage a real browser like Firefox or Chrome to process any scripts attached to the website and retrieve the resulting HTML code. Instead of parsing link directly from HTTP response, it will do so from the result of the web browser processing the website. This can be achieved by using the AJAX spider. Okay, so let's see how we're gonna do that. Leveraging a real browser is highly advantageous, as Zap does not have to deal with all the intricacies of current JavaScript engines, but rather delegates this task to a browser, guaranteeing that the result will match what a user will see if they use the same browser. Okay, that's what we will do. Using the AJAX spider is a similar process to the regular spider. Just go to the tools AJAX spider, configure a URL as a starting point, and check the options you see fit. I will use the Firefox browser, and you can see here the only new option you have is the browser selection, where we will choose Firefox this time. The list of browsers also has headless option, which will run selected browser without showing you a graphical interface. But for now, let's stick to regular Firefox, as it makes it easier to understand how the AJAX spider works. Your configuration should look like below. Let's do that. I'm gonna leave the Mozilla as it is. Go to the tools. There is a AJAX spider. Let me copy paste the URL. And I will use Firefox, not the headless option, because we want to see what is happening during the scan. Let's hit this start scan. To make it work, you should see the Firefox popping up and navigating the website for a bit. While the AJAX spider is done, it will populate the site in a Zap just as the regular spider. Since the AJAX spider leverages the power of Firefox to get better result, you should now see non-spider-gallery.php in your site's list in Zap. Yep. Okay. Here is our Firefox. And it is automatically navigating to different pages, as you can see. Yeah, it is going to non-spider-gallery.php as well. I don't know if it is opening multiple instances. Okay, so it is done. AJAX spider is done, as you can see here. Many of the things are out of the scope, as you can see. Location.services Mozilla is out of scope. Rest of everything is there, and we will be able to see the non-spider gallery.php as well. And as you can see, we got it through AJAX spider. Okay, red ones are AJAX spider. Awesome. We have done so. Since the AJAX spider leverages the power of, we have done so. Zap can run a AJAX spider by using browser without a graphical user interface. What are these browser called? Headless. Okay. Analyzing sites tab. What HTML parameters can be passed to login.php using the post method in alphabetical order and separated by comma? Okay. They are saying post, right? Post method. So this is post, and this is also post. So it is pass and user. P and U, pass and user. Pass user. Awesome. What other .php resources beside the non-spider gallery.php was found? by the AJAX spider, but not by the regular spider. I think favicon icon, right? Let's see. Yeah, view.php. 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 I think so. Awesome. So guys, we have done task 1, 2, 3, and so once we come back, we'll start task 4, 5, and 6 hopefully, and by the end of that video, we'll be able to complete the rest of the task. Maybe in next 3 videos, we'll be able to done with this room. Thank you very much for joining me on this journey. It was really nice learning a lot of good stuff in this room, and obviously DAST is really important if you're building a secure software development lifecycle. So thank you guys for all the support and love on this channel. Once we come back, we'll start the scanning for vulnerabilities. Thank you very much. And if you haven't subscribed, please subscribe. Help us achieve at least 1,000 users by August 2024. I hope we'll be able to do this by your support. Okay, if you like this video, please give it a thumbs up. If you have any suggestion, please put the comments below, and I will see you in the next video. Thank you and bye bye.